Hello, welcome viewers to this platform, and also welcome our new viewers to this virtual learning platform. And I recommend that you subscribe to this channel and share with your friends. This lesson 4 on probability, simple probability tree diagram. This is the very simple version of probability tree diagram. And in our final lesson, lesson 5, we talk about probability tree diagram without replacement and probability without using tree diagram. So this is the simple version of probability tree diagram. Things that I need you to know before I start is that in drawing the tree diagram, each pair of branches probabilities must add up to 1. Second, we always move along the branches to calculate probability, and when calculating probability, we always multiply as we move along the branches. We always multiply. So let's look at our first example. Please pause the video to always read the question yourself to understand. So here, Michael plays 2 games in a fanfare, board game and ball game. Probability for each game is given. Now you need to remember that probability for each game is different. So in terms of using tree diagram, it's mainly for events whose outcome are not equally likely. Unlike the sample space diagram, we do it for equally likely outcomes. This one is for non-equally likely outcomes as well. Okay, so here we are supposed to complete the diagram and work out probability. Now, like I said, each pair must add up to 1. So if to win is 0.3 for board game, then to lose is the opposite. How much to add to 1? 0.3 to get to 1. Take 0.3 from 1, that gives you 0.7. Ball game is 0.6. So to lose ball game should be 0.4. Now don't confuse yourself as to why we have 2 of this, because there's a condition. The condition here is that on this branch you've already won board game, so you can still win ball game or lose ball game. Here we'll repeat it because we are assuming that if you've lost board game, you can win ball game or you can lose ball game. That's why it's like this. Most of the time when I finish this, you need to understand that these two will be the same. So we repeat that. I always label my work with letters to help me identify my lines. So WW is from this line, WL is from these 2 lines, LW is from these 2 lines, and LL is from these 2 lines. It helps me to know my answers easily. So to win both games, we have WW, that's win and win. And I know this comes from 0.3 and 0.6. Like I said before, we always multiply when moving along the probability. So that gives us 0.3 times 0.6 is 0.18. B, the chance that you lose 1 game. Here we win, we lose. We lose, we win. So 1 game, we lose. 1 game, we lose. We win all, we lose all. So we are talking about these 2. Work each separately. Win and lose is 0.3 and 0.4. Lose and win, 0.7 and 0.6. All together makes 0.54. At least win a game. When you say at least win a game, that means you win 1 game or you win all the games. At least win a game means you win only 1 game or you win all the games. So it's here we win 1 game, we win 1 game, we win all the games. We're looking for these 3 options. But the easy way of working these 3 options is to work out this simple option and take it away from 1. Remember, we said all together should add up to 1. So if you want only these 3 answers, work out lose and lose and take your answer away from 1. That's easier, and that gives us 0.72. Example 2. Pause it and read the question. Okay, so 4 blues and 5 green pencils. You take a counter and you replace it. So because you replace after each pick, the outcome will be the same every single time. The first and the second pick will have the same probability because we replace the color that we picked earlier on. So to pick a blue is only 4 chance out of 9. A green is 5/9. The same thing, you repeat, because the outcome is the same. Let's label our branches. So this is the labeling. Pick the same color. Okay, we have blue and blue and green and green. So these are the two options. Work each out. Blue and blue is 4/9 times 4/9. Green and green is 5/9 times 5/9. That gives us 41/81. Exactly 1 green pencil. No green pencil. 2 green pencils, but we want exactly 1. So these are the two options. 2 green pencils. Blue-green is 4/9 times 5/9. Plus green and blue is 5/9 times 4/9. And that gives us 40/81. Last one, at most 1 blue pencil. At most means the maximum number of blue you should have is 1. Only 1. Maximum number of blue pencils you should have is 1, or no blue at all. So we are looking for blue and green, green and blue, and green, green, no blue. So it's the reverse of at least. So to work out these 3 options, we work out what we don't want and take it away from 1. And we know BB is 4/9 times 4/9, which is 1/16. So 1 minus 16/81 is 65/81. So 4/9 times 4/9 is 16/81. So taking away from 1 is 65/81. Example 3. Pause the video and read the question. Okay, so the probability that the bus, a community bus arrives late is 0.4 for both days, Saturdays and Sundays. Joseph is traveling by a bus on Saturday and Sunday. Complete the information, then calculate probability that the bus is late in one of the days. Okay. Now, a bus is either late or early. We said it's late 0.4 on Saturdays and Sunday. So we put 0.4 for late, and all the late should have 0.4. Now we know each branch should add up to 1. So 0.4 from 1 will give you 0.6. So early will be 0.6, and all early should also have 0.6. Label your branches: early, 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 late, late, early, late, late. We want probability that is late in one of the days. Late in one day, late in one day. So 2 options here. So you work it out. 0.6 times 0.4 is early and late. 0.4 times 0.6 is late and early. And that gives us 0.48. Right. Now, last example. Pause it and read it, please. Okay. In a village, there is one library, and the library, whether it's going to be open, it depends on whether it's raining or not raining. And we have probability of raining in the village is 0.2. And if it rains, the probability that the library will be open is 0.4. But if it does not rain, the probability that the library will be open is 0.9. We need to represent this on a probability tree diagram and use it to work out the number of days the library will be open over 60 days. Now, you have to understand that the library will be dependent on whether it's raining or not raining. So it's best to start with the option of raining and not raining. So we have option of raining. What's the probability of raining in the village? We have 0.2. Then what is the probability that it will not rain? The opposite is 0.8. Okay. Now we've been told that when it rains, the chance the library will be open is 0.4. So let's look at opening. It's 0.4 chance. What about not opening when it's raining? It will be the opposite of 0.4, because we need to make sure we add up to 1. That's 0.6. When it does not rain, we are on this line. the library will be open at a chance of 0.9. So opening is 0.9. What about not opened? Opposite of 0.9 to get 1 is 0.1. Now it's been labeling as well. Raining and opening, raining, not opening, not raining, opening, not raining, not opening. Now we need to work out the probability that it will be opened within 60 days. First, we must know the probability of the library being opened. We have probability that it will be open, two options. Library being open when it's raining and library opening when it's not raining. So when it's raining and opening, we have 0.2 and 0.4. 0.2 times 0.4. Not raining and opening is 0.8 times 0.9. So in all, the chance of the library being opened is 0.8. So you have 0.8 chance the library will be open. Now, over 60 days, we need to multiply our probability by the number of days the library is expected to be open. That is similar to what we did before in relative frequency. So we multiply the probability that is going to be open by 60 days. And we have 48 days. So we expect the library to be opened in 48 days out of 60 days. That brings us to the end of our lesson 4 on probabilities tree diagram. Watch out for the last lesson on tree diagram without replacement and probability without using tree diagram. Thank you very much for watching. Share with your friends and subscribe to this channel. Thank you.